Okay, one thing before going to the next unit, there is a paper by Fayad, classic paper, written in 1996 called the KDD, Knowledge Data Discovery Paper. And take a look at that paper, go through that paper at this point here. Let me move to the next section called the dark side of data mining. Whoop. And you see Darth Vader there, and we've got a quote from Einstein: "The release of atomic power has changed everything except our way of thinking. The solution to this problem lies in the heart of humanity. If only I'd known, I would have become a watchmaker." So there's a couple things that can happen, and as any technology, can be misused or abused. And I'm going to present some of the common and relevant issues and devious tactics related to data mining. Before I go on, there is a slideshow by John Elder called Top 10 Data Mining Mistakes. Please take a look at that now before going on. Okay, and once you've finished that, it's on the Google Drive. You'll see it on the Google Drive there. One issue is data mining and privacy. And one of the things that happens is that violation of privacy is happening more and more, and you hear the recent politics between President Trump and Hillary, how they eavesdropped on each other and did all these issues. And so on a personal basis, as a citizen of a country, there's a danger of the government using data mining to track its citizens in a very inappropriate way. So we have renewed secret U.S. surveillance programs, National Security Agency collecting U.S. email records, some pretty scary stuff that's going on there. Now here's an example, caveat emptor, which means let the buyer beware. Data mining can sometimes misrepresent results. And I used to use a software program, I won't say the name of the program, and they literally sent me this brochure. I didn't create it. I blocked out the name of the company. And they say, attend a 2-day investment seminar. Learn how to create and conduct strategies that have gained more than 4,000% in 24 months. And I think, wow, that sounds fantastic. Learn how to value stocks, assess safety, pick surefire winners, when to buy, when to hold. Learn how their model predicted the bull rally in October 22nd, 1999, peaked in 2000, and a system that's never failed. That's a major claim. Now what they show here is that their model, the green arrow means it says buy here, red means sell there, green means buy there. And they claim, oh, our model said to buy here, it said to sell here, and to buy there. And indeed, their model did say to buy, sell, and buy at those points. However, what it did not tell you is that they filtered out and left out a lot of the bad signals. So they also might have had a buy up here, they might have had a sell down here. So not all the signals were good. And so they filtered out only the best ones they wanted to give the illusion that it is a very good model. And this gentleman, CEO of the company, came to Houston in 2000. There's a hotel called the Houstonian. And I went to his presentation, and what he did, I don't know if I have it here, nope. What he did was he started with the model in 1996, going back testing, starting with $100,000, and he was doing this live on historical data. He went from $100,000 to $20 million. And people, their jaws were dropping, saying, oh my goodness, what a fantastic model. Well, part of the problem, it was not realistic, because let's say you had $1 million in your account, and you're going to invest, let's say, $100,000. Well, in his model, he might buy a penny stock for 5 cents, turn around and sell it like a couple days later for 25 cents, and claim that the $100,000 is now worth $500,000. Well, the reality is, if you have $100,000 in a stock selling for 5 cents, you can't do that, because as soon as you start buying, it's going to drive up the price dramatically. So it ignores certain assumptions like that, and wasn't realistic. So caveat emptor, let the buyer beware. And another example, a friend of mine in Dallas had a model that went from 100,000 to 8 billion in 5 years. Now that is extremely unrealistic, because once again, when you have lots of money, it's hard to go in and out of the market on a day-by-day basis. Typically, the more money you have, it takes you a couple days or even weeks to get into a position, and it takes you a couple days or weeks to get out of a position. So it's not that easy, and this is like very unrealistic, this graph here. Sometimes what happens, here's a graph for Microsoft, and another graph. This is a linear graph, this is a log graph, and this one, exact same data, this one looks a lot better, and so the way you represent the data can be deceptive also. Now, sometimes what happens, let's say you're at a company and a stock goes from $100 down to $60. The problem is, this looks really bad. Here's the exact same graph, except now we put a lower point of like 0 and a higher point of 200. So essentially, it flattens the slope of the graph because of increasing the Y value range in this case. So things like that can happen and diminish the losses, but they're exact same graphs there. Also, there's a nice web page, showing you some interesting visualization there. This was actually from the election Fox News and the GOP candidates 2012. So we had Sarah Palin, Romney, and Huckabee. But notice the numbers, 70, 60, 63. How do you add up and get, it's not 100%, it's like 100 and almost like 200% if I ballpark. So a little boo-boo there. Here's another pie chart, kind of a amusing joke. And then there's this example here, and the government spent this money. The Department of Defense spent money on what's called finding tanks in photos, and they had like 10 photos, and they were like a nature background with a tank in the photo, and then there were 10 more photos. There was no tank in the photo, and they used machine learners to see whether it could find the tank or not, and the software worked fantastic in terms of finding the tank in a picture or not finding the tank in a picture. Well, then they went out and took other photos, and the software did a terrible job at finding the tanks. And they said, well, what happened here? Why was it able to find the tanks in one photo and the other, but then we had new data and it just failed miserably? Well, it turns out the day that they took photos with the tank, the sky was gray like shown here. And then the next day they took photos without the tanks, it was a pure blue sky. So it turns out the software was not finding the tanks, but identifying the type of sky in terms of whether or not the tank was in the picture. So sometimes you can get results like that, and it can create a awkward situation in terms of funding. So we also want to validate others' works, and we ask the other miner maybe a description of the model. So you might be the one they're asking. You want to describe the model. You want to see what results you get. See if there's any industry standards, like in software estimation. Usually it's an error of 25% is considered acceptable. And one of the things is that not aha, but we come up with, well, that's odd. So sometimes you do modeling, you might make some assumptions, and you learn that you might have had assumptions and it might reveal something you hadn't thought of before. Well, what we have here are review questions and exercises, and please go over those on your own time, and that'll end the review of the Unit 1 notes. Thank you very much, and see you soon. Bye-bye.